Hi friends, in this video let us talk about common source circuit with the source resistor. Right, in the previous video I have dealt common source circuit without source resistor. Now I add source resistor. So here the circuit will be like this. Here the supply and bias resistor in the left hand side as usual. This is R1, this is R2. We know these two are bias resistors. And we have MOSFET here. It is NMOS circuit I am taking, so it will be like this. And here I have to add drain resistance RD. This is RD, and here I add RS source resistance. So this is newly added. Fine, and it is NMOS circuit. Here you see this is what I have added newly. So what is the role of the resistor? Let us see. Fine. Okay, as usual we know that VG, right? We will find here the drain current, gate current is 0, so no current flows through gate since gate is insulated. So IG 0, so all the currents flowing through R1 will go to R2 only. So R1 and R2 are in series, so I find what is the voltage across R2, which is nothing but gate voltage. This is gate terminal. So VG is equal to VDD, total voltage. I apply voltage divider rule, corresponding resistor divided by total resistor. Now I apply KVL to the input circuit. So here I apply KVL here, right? So this is here plus VG, here yes. So this is called VGS. So from here I start VGS first voltage plus VGS. So here the voltage between these two terminals is VS. So VG plus VS, and it is coming here. It is plus VG. It is VG. This voltage is VG. Voltage across R2 is VG. So plus minus, what is minus? So minus VG equal to 0. This implies VGS. VGS equal to VG minus VS. VG minus VS. So VS is voltage across resistor RS. So here the current flowing through the drain is drain current, and there is no gate current, so all the drain current will flow through source. So it is current flowing through this is ID, which is equal to IS. Both are same. So I can write VGS is equal to VG minus IDRS or ISRS. Both are same, right? So VGS is equal to VG minus IDR. These two are important formula. Okay. So once we find VGS, this is what we want to find. Next, what we have to find, we apply this is KVL at input side. Now we apply KVL at output side. This is output side, right? So here you apply KVL, this area. So what will happen? It is VDD minus IDRD. VDD is supply. The drop here is IDRD. And the drop here is ISRS, which is nothing but IDRS, which is equal to 0. So this implies, and we have one VDS. So here I have one V. So here we have VDS. So I write one more minus VDS. Minus VDS is equal to 0. This implies VDS is equal to VDD minus ID RD plus RS. Right? So VDS, this is the first thing we have to find for any network. ID we know. For ID for saturation region is Kn VGS minus VT square, and saturation means VGS must be greater than VT. So these two conditions must be satisfied. So this is ID. So for any MOSFET circuit, we have to find the drain current and the drain to source voltage. We found both here, right? Okay. Now let us solve one problem from this area. So here supply voltage is 40 volt and we have bias resistors with value 22 mega ohm, fine, and here we have 18 mega ohm. This is MOSFET, and we have a source system, right? Here we have 3 kilo ohm, and here we have 820 ohm NMOS. What we have to find and what are the things given, and they have given VT is 5 volt, VGS on is 10 volt, and ID on is equal to 3 milliampere. What we have to find is find VDS and ID. This is the question. So these are all the details given. So first, as usual, we find what is VG. VG we know it is VDD. VDD is 40 into, this is R2, this is R1. So 40 into 18 divided by R1 plus R2, 40. So VG 18 volt we got. Next, what we have to find? We have to find VGS. We know VGS is equal to VG minus ID RS, right? So ID VG 18 volt, ID I don't know, RS is 820 ohm, so it is 820. Okay, now we have to find ID. To find ID, what I have to find? I have to find ID is equal to Kn VGS minus VT square. So I don't know what is Kn. So first I find Kn. Kn is equal to ID on divided by VGS on minus VT square. VGS on minus VT square. From this only I write Kn is equal to ID on divided by VGS on minus VT square. So everything is given. ID on, they have given ID on, VGS on, VT, everything they have given. So if you simplify, what you get is IKN is equal to 0.12 into 10 power 3 ampere per volt square, that is 0.12 10 power milliampere per volt square, right? Now we will find ID. ID is equal to Kn, it is 0.12 into 10 power minus 3. VGS, we found VGS. VGS is equal to 80 minus 820 ID. VT is 5 as per the problem. VT they are given, right? Here I substitute this one, right? Kn I substitute. VGS we found 18 minus VGS is here, right? This is what our VGS, right? 18 minus 820 ID. VT is 5. It is given in the problem. So if you simplify, what you get is, I get ID as 37.38 milliampere, or ID is equal to 6.725 million. It is in square, so it is a quadratic equation. We will get 2 ID. So and we have to choose which ID is the apt answer. So what I am going to do? So by using ID is equal to 37.38 milliampere, I find VDS. VDS we know, VDS equal to VDD minus ID RS plus RD. Everything is there. ID is there, VDD is given in the problem, RS, RD, everything is there. If you substitute all the value, what you get is minus 102.8 watt. So this is VDS. Same thing I apply, ID is equal to 6.725. This will give VDS is equal to 14.31 volt. So which answer is correct, that we have to choose, right? So we assumed the device is in saturation. then only we apply the formula ID is equal to K into VGS minus VT squared. Since device is in saturation, we must know VDS must be greater than VGS minus VT. VGS, what is VGS? Right? So we will substitute all the values. So VD sat, this is what VD sat we know. It is minus 102.8. VGS minus VT. VGS on minus VT on. You see what is VGS minus VT? On voltage. They are given VGS minus VT. VGS is 10, VT is 5. So 10 minus 5 is 5. Right? So 10 minus 5 is 5. So this is less than this one. So this is wrong answer. Right? So what will be this VDS? Here VDS is 14.3. This is 5. So again VDS, VGS minus VT I find. So this condition is fulfilled. So for saturation we know VDS must be greater than VGS minus VT. So when VDS equal to 14.3, the device is in saturation. So what we get is VDS is equal to 14.3 volt. This I obtained for ID is equal to 6.725 milliampere. So ID is equal to 6.725 milliamp. Right? So this is what we have to find. Right? I hope you understand this. If any doubt, ask in comment section. I will clarify. Thank you.